Alright, this is going to be Geometry Lesson 7-6. We're talking about center circles, or the center of circles. So I want to start with a review from yesterday. I didn't quite go over this formally, I did it on the board, kind of informally. But if I have an angle at the center versus an angle at the circumference, so let's look at what I mean by that. If I have an angle that looks like this versus an angle that is using the same part of the circumference down here. So if I'm looking at this angle right here versus this angle down here is kind of what it's looking at. The center at this center, if that one was, I don't know, we'll make it 20. That angle is going to be twice the angle at the circumference down here. So at the circumference is going to be 10. So you always half it if it's touching the circumference. And the other property that we found yesterday was that if we have two chords that are equal, for example, if we had a chord like this and a chord like this, they should be touching the circumference, the outside part of the circle. And if I said that those two chords are equal, or if I just said that the angles were equal, you go back and forth. So I could say if the chords are equal, if they're congruent, then these must be something like, if this one was, I'm not going to use 10 here, I'm going to use like 30 degrees, then this one should also be 30 degrees. And if I just gave you 30 degrees, you could go ahead and make the tick marks from the 30 degrees. You can go backwards and forwards. So the new stuff today. Equal chords are equidistant from the center. And going back and forth, you can go backwards to say if you have something that is equidistant from the center, then those chords must be equal. Let's see what that looks like. So let's draw two chords, a chord like that and a chord like that, and then let's do a line that goes to the chord and a line that goes to the chord. So this radius, the partial radius, needs to meet at a right angle here. At a right angle. That is the distance from this chord to the center of the circle. So this is saying if those chords are equidistant from the center, or sorry, if these are equal chords, so I'm going to say that this chord right here was, we'll say A, B, and this chord here will be C, D. So if I say A, B, that chord is congruent to CD, then I also know that these two lengths, because of this, you start here, maybe I should label this with a 1. From here, you can get to step 2. From here, you can say that these two are the same. So if these two chords are the same, these two lengths have to be the same. And you can go backwards too. If I say that these two lengths are the same, then you can say these two chords are the same. Alright, the last theorem that you need to learn today is the perpendicular bisector of a chord passes through the center of the circle. This one is straightforward as well. So if I draw some chord and I do a perpendicular bisector, we know how to construct that, but it means that I'm cutting it in half. Bisect means perfectly in half, and it's perpendicular. So it should look like that. So I cut it in half so that this segment and this segment are the same, and it's at 90 degrees, it's perpendicular. If that happens, then this line should go through the center of the circle. All right, let's see an example. So in example 1, I'm saying that the measure of AB, this arc is 70 degrees. Then what is the measure of CB? Well, I know that these two chords are equidistant from the center. This was the center. Therefore, these two chords must be the same. So this chord must also be congruent. So I can say that in red or something, that this chord must be congruent to this chord, this entire chord. And because of that, I can use this theorem that we have from yesterday, that equal chords means I have equal angles, and therefore this angle must also be 70 degrees. In the last example, what is the perimeter of W, X, Y, Z? So on this problem, I have this length, but I don't have this length and this length. I need to find them. But look, I know that because I have a perpendicular bisector here, or because I have the length of this chord, or the length of this radius is going through the center, I know that this is going to be a perpendicular bisector. And perpendicular bisectors are always cut in half, so if this was 10, then this must be 5. If this was 6, this must be 3. And then I can add all these together. 3 plus 5 plus 5 plus 2 is 15. So the perimeter is equal to 15. And that's it for the notes.